Hello students, today we start a new chapter, inequalities in triangle. New part of the chapter 7. Inequalities in triangle. Inequalities. What are the inequalities in triangles? First thing, if a triangle has all three sides equal in length, one thing should be marked well forever that whenever we compare geometrical facts like lines, angles, triangles, quadrilaterals, etc., circle, square, these figures are the sets of points, and these figures are union of infinite number of points. It is not possible or feasible to equate one infinite number with the other infinite number, but we can certainly equalize one definite number with the other definite number. For example, 5 is to 5 or 5 is to half of 10. So whenever we consider the equalities or inequalities, we should bear in mind that equalities of two line segments refers to the equality of their lengths. Suppose the line segment is of 5 cm and the other line segment is of 10 cm. We can say that the line segment with 10 cm length is larger than the line segment of 5 cm. But if we consider the points in a line segment of 5 centimeters and points in line segment of 10 centimeters, they are all infinite. Suppose we say that two line segments are of equal length, say 5 centimeters. Then we say that the line segments are equal in the sense of their lengths, not in the sense of their number of points in them. If we try to say something about related to the number of the points, we can say that line segment of 5 cm AB, say, is congruent with the line segment of length 5 cm PQ. Line segment PQ of 5 centimeters. So whenever we say with respect to the number of points, we say congruency. But equality refers only with the measure, definite measure. When we say that two angles are equal, they are equal in the sense of their measures. If a triangle has all three sides equal in length, then all its angles will also be equal in length, and each one will be 60 degrees. This we have already learned. And converse of the above statement is also true. What is converse? If in a triangle all angles are each of 60 degrees, then all its sides will be equal in length, or all its sides will be equal, we can say. Now, if a triangle has two sides of equal length, then the angles opposite to these sides are also equal in measure. Consider triangle ABC. In triangle ABC, side AB and AC are of equal lengths. So the angle opposite to side will be that is angle C, and angle opposite to side AC, that is angle B, will also be of equal measure. Angle A and angle B may not be equal, but angles opposite to the sides will be equal if the sides are equal. And the converse of the above statement is also true. What is the converse? We have the statement in a triangle, if it has two sides of equal length, then the angles opposite to these sides are also equal in measure. Converse. If a triangle has two angles of equal in measure, then the sides opposite to these angles will be equal in length. Thus, the converse of the statement is also always true. Here we have another triangle PQR in which two angles Q and R are of equal measure. Therefore, the side opposite to angle Q, that is side PR, and the side opposite to angle R, that is side PQ, will also be of equal lengths. Thus, PQ and PR will be equal sides. Now, here we have considered all three sides equal, here two sides equal, and here all three sides of different length. What is the type of this triangle in which all three sides are equal? Yes, it is an equilateral triangle. Lateral means sided. A triangle with all sides equal. We can also say that it is also an equiangular triangle. Equilateral, equiangular. Here, what is the type of this triangle in which two sides are equal in length? Yes, it is an isosceles triangle. Iso means same, celes is angled. Means there are two angles of equal measure, and the sides opposite to these two angles are also of same length. Now, suppose a triangle is given such that all three sides are of different lengths. No two sides are equal. One is smaller, the other is bigger than that, the third is biggest of all. That is a scalene triangle in which one side is the largest, one side is the smallest, and the third side, other than these two, is smaller than larger than smaller. Now consider the scalene triangle ABC. ABC are the vertices of triangle. It is customary to denote the vertex of a triangle with a capital letter, and the length opposite to this vertex by a small letter. A small letter denotes the length of BC opposite to angle A. Similarly, over here, small b denotes the length of side AC, which is opposite to vertex B, and small c denotes the length of side AB opposite to vertex C. It is the customary method of expressing various vertices and various lengths of the sides in geometry. Here we have length AB equal to C, length BC equal to A, length AC equal to B. Now it is given that A is greater than B is greater than C. This is the largest side and this is the smallest side. this side is smaller than largest and larger and bigger than the smallest. So B is bigger than the smallest side, C, and smaller than the largest side, A. So the fact is that the angle opposite to the largest side will be of largest measure. The angle opposite to the smallest side will be of smallest measure. Therefore, we can, if it is given A less than B, A greater than B, greater than C, then we can say that measure angle A is greater than measure angle B is greater than measure angle C. So, it is very plain fact that angle opposite to the largest side is the largest. Now, converse of the above statement is also always true. If a triangle has all three angles of different measures, then the side opposite to the largest angle will be the largest, and side opposite to the smallest angle will be smallest. So this expresses the relation between lengths of sides and measures of angle in a scaling triangle, where all three sides are of different lengths. No two sides are equal length. Converse. How do we write converse of this statement? If in a triangle it has all three angles of unequal measure, then the side opposite to the angle with largest measure will be the largest, and the side opposite to the angle with smallest measure will be smallest. Converse is also always true in this inequality. Mark this inequality, which is not very difficult. It is very easy. Side others opposite to largest angle is largest, smallest angle is smallest, like that. Now, an important property of any triangle, whether it is scaling or an isosceles triangle or an equilateral triangle. Let there be any type of triangle, equilateral, isosceles or scaling. Here is an important property of any triangle. It states that the sum of lengths of any two sides in a triangle is always greater than the length of the third side. The length of the third side. The third side is the length of the third side of the third side. Let there be A, B and C, the lengths of three sides of the triangle. Then sum of two sides AB is greater than the third side C. Sum of two other sides BC is also greater than the third side A. Similarly, sum of these two sides A and C will be greater than B. Means sum of any two sides Now, what about the difference of any lengths of any two sides? It is a very important peculiar point. The difference should be positive difference. Positive difference we write A minus B. If A is greater, this will be positive. If B is greater, then subtract B from A and take the positive value. Is always less than the third side C. And the third side C will always be less than A plus B. This is a very important property of triangle. The positive difference of any two sides of a triangle is always less than the third side, which is always less than the sum of the other two sides. So this is very important property of any triangle. Here mark it well that the difference we take is the positive difference. Means we have to subtract greater side from the smaller side other than the side we take. Thus AB is greater than C, that is C is less than A plus B. Sum of two sides A plus B is greater than the third side. And the other way also we can write A plus B is greater than C is greater than A minus B, the positive difference between two other sides. So dear students, try to learn this well and practice. Thank you.